Hello viewers, in today's session we are going to discuss another important conceptual problem from differentiation, right? So in this session we are going to discuss this problem in which we are given a function f of x, which is a combination of absolute value function and the greatest integer function, right? And here f of x is given as the mod of x minus 2 multiplied with greatest integer of x minus greatest integer of minus x, and we have to find out the value of the derivative of this function f of x at 2, right? So here we have two parts here. In the first part we have to find out the right hand derivative of f of x at x is equal to 2, and in the second part we have to find out the left hand derivative of f of x at x is equal to 2, right? So here what we will do, will make use of an important property of greatest integer function, right? And then we'll see how we can redefine this function f of x by making use of the property of greatest integer function, right? So let us first see the important property of greatest integer function, which helps us to modify this function f of x, and then we'll find out the left hand derivative and the right hand derivative of this function f of x at x is equal to 2. So let us start. So let us first consider the property of greatest integer function, right? So here if we have greatest integer of x minus greatest integer of minus x, then this expression is equal to 2 times the greatest integer of x plus 1 whenever x does not belong to the set of integers, and this expression is equal to simply 2 times the greatest integer of x when x belongs to the set of integers, right? So we can also verify this property by taking a particular value. So let us quickly take x is equal to say 2.1, right? And here 2.1 is not an integer, right? So the greatest integer of 2.1 minus greatest integer of minus 2.1 is equal to 2 times the greatest integer of 2.1 plus 1, right? So the greatest integer of 2.1 is simply 2, and the greatest integer of minus 2.1 is minus 3. So here we have 2 plus 3, that is 5, and here we have 2 times the greatest integer of 2.1, that is simply 2, and here we have plus 1, so this is 4 plus 1, 5, right? So when x is not an integer, then the value of this expression is equal to 2 times greatest integer of x plus 1, as we have just seen by taking x is equal to 2.1. Now let us take x as an integer. Suppose we have x is equal to 2. Now 2 is an integer, so the value of this expression is greatest integer of 2 minus greatest integer of minus 2, and here when x is an integer, then the value of this expression is 2 times greatest integer of x. So here we have greatest integer of 2 times greatest integer of 2. Now here we have 2, and the greatest integer of minus 2 is simply minus 2, right? So here we have 2 times greatest integer of 2, which is 2. So this is 2 plus 2, and here we have 4. So 4 is equal to 4, right? So this property is very useful while solving this problem. So now here we have a mod of x minus 2. So let us see the definition of mod function. So mod of p is defined as positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So here we have for p we have x minus 2. So mod of x minus 2 is positive x minus 2 whenever x minus 2 is greater than 0. It implies that x should be greater than 2, and mod of x minus 2 is 0 whenever x minus 2 is equal to 0, that is x is equal to 0, and mod of x minus 2 is equal to negative x minus 2 whenever we have x minus 2 less than 0. So it implies x less than 2, right? So to solve these kind of problems we must know the definitions of the functions involved, right? So now let us modify or rewrite this function or redefine this function by using these two definitions. So now we can write f of x is equal to positive x minus 2. Here a mod of x minus 2 is taken as positive x minus 2 whenever x is greater than 2. And here the greatest integer of x minus greatest integer of minus x is now taken as 2 times the greatest integer of x plus 1. So here the condition is that x should be greater than 2, and x should not belongs to the set of integers, right? And f of x can be written as negative x minus 2, and here we'll write the expression for greatest integer of x minus greatest integer of minus x as 2 times greatest integer of x plus 1 whenever x is less than 2, and here again x does not belongs to the set of integers, right? So here we have now redefined the function f of x in this manner, and moreover we have to write here f of x is equal to mod of x minus 2, and when we are taking x as an integer, then the greatest integer of x minus greatest integer of minus x should be replaced by 2 times the greatest integer of x. So here we must have 2 times greatest integer of x. So when x it belongs to the set of integers. So now we have to find out the right hand derivative and the left hand derivative of this function at this point, that is x is equal to 2. So let us define the right hand derivative by this limit, that is limit h tends to 0, and we have f of a plus h minus f of a, and here we have h. So here for right hand derivative we can write f prime of a plus. So here we are calculating the right hand derivative at this point, that is x is equal to a. And similarly we can define the left hand derivative, that is f prime, and here we have a negative. So positive sign shows that right hand derivative, and negative sign shows that left hand derivative. So the left hand derivative is defined by this limit, that is f of a minus h minus f of a divided by minus h. So in this case the value of a is equal to 2. So let us first find the right hand derivative. So we can now write here f prime of 2 plus, replacing this a by 2, we have limit, and then we have h tends to 0, f of 2 plus h minus f of 2 divided by h, right? So now we have to find out the value of f of 2 plus h and f of 2. So let us first find f of 2. Now see, when we have f of 2, so here we have the integer 2, right? That is x is equal to 2, which is an integer. So f of x is now defined as mod of x minus 2 times the 2 times the greatest integer of x. So we can now write f of 2 as mod of 2 minus 2, and here we have 2 times the greatest integer of 2. So mod of 2 minus 2, this is 0, so this entire term reduces to 0. So we have f of 2 equal to 0, right? So see, when we find out the value of f of 2, so 2 is an integer. Now when x is an integer, then the value of this expression is equal to 2 times the greatest integer of x, right? And here a mod of x minus 2 remains as such. So when we take f of 2, we replace x by 2. So here 2 minus 2 is 0, so this entire term reduces to 0. So f of 2 is 0. So here we have now limit h tends to 0 and f of 2 plus h divided by h, because this term is 0. So now we have to find out the value of f of 2 plus h. Now see, here 2 plus h. Now h is a positive number and it is infinitesimally very small. So 2 plus h is greater than 2, right? Or we can write 2 plus h greater than 2, where h is a positive quantity and it is infinitesimally very small. So when x is greater than 2, so here we'll apply this form of the function f of x, and moreover here x is not an integer, right? So to calculate f of 2 plus h, we'll first see that this 2 plus h is greater than 2, right? So now we have limit h tends to 0, f of 2 plus h can be obtained by replacing x by 2 plus h. So here we have 2 plus h minus 2, here we have obviously the positive sign, and then we have 2 times the greatest integer of x, that is greatest integer of 2 plus h, and here we have plus 1, and in the denominator we have h, right? Now see, this 2 and this 2 get cancelled, and here we have greatest integer of 2 plus h. Now see, 2 plus h is slightly greater than 2, but it is less than 3. So by the definition of greatest integer function, the value of greatest integer of 2 plus h should be equal to 2. So here I will write for greatest integer of 2 plus h equal to 2. So now we have limit h tends to 0, and here 2 and 2 get cancelled. So we have simply h, and here we have 2 times 2 plus 1, and here we have h. Now this h and this h get cancelled, and now this term is a pure number and it is independent of h. So we can now omit, or we can neglect this limit notation. So we have 2 times 2, 4, and this is plus 1, that is equal to 5, right? So the right hand derivative of this function f of x at this point 2 is equal to 5. So now let us calculate the left hand derivative. So here we have f prime of 2 minus, because now a is here 2, so we have 2 minus, and this is limit h tends to 0, and we have 2 minus h minus f of 2 divided by minus h. Now f of 2 we have already calculated, this is 0, so we have simply limit h tends to 0, f of 2 minus h divided by minus h. Now let us concentrate on this number, that is 2 minus h. Now h is a positive quantity and it is infinitesimally very small, so 2 minus h is less than 2, right? So it means now we have to apply this form of the function f of x, because here we have x less than 2, right? And obviously x does not belongs to the set of integers. So 2 minus h is less than 2. So now we have limit h tends to 0, and we can now replace here x by 2 minus h. So we have minus 2 minus h minus 2, and then we have 2 times the greatest integer of x, that is 2 minus h. Here we have 1, and now here we have minus h. Now see, this 2 and this 2 get cancelled, and here we have greatest integer of 2 minus h. Now see, 2 minus h, this 2 minus h is slightly less than that is it is less than 2, but it is greater than 1. So 2 minus h, it lies between 1 and 2. So by the definition of greatest integer function, the greatest integer of 2 minus h should be equal to 1, right? So now here we have limit h tends to 0. Here we have the negative sign, then we have minus h, and here we have 2 times the greatest integer of 2 minus h, that is 1, and here we have plus 1, and in the denominator we have minus h. So we have limit h tends to 0, this is minus minus plus, so we have positive h, and here 2 times 1 is 2, 2 plus 1 is 3, and here we have minus h. Now this h and this h get cancelled, so we have limit h tends to 0, and here we have minus 3. So now we can omit this limit notation, because minus 3 is independent of h, so we have simply minus 3, right? So the value of the left hand derivative of f of x at this point 2 is equal to minus 3.